Now, the first test, hopefully by now you've read the directions and you understand that you're testing the samples and their solubility. You want to see if they can dissolve in water or not. So we've got the results here, or at least I've got a picture of the results, same ones you saw in the Google form. But here are the 3 substances that come out cloudy. That's what you were supposed to be looking for as a positive result here. They're cloudy because they're not dissolved. They're shaken up, they're mixed, but if you let these guys settle for the next couple minutes, you're going to see that that white solid is just going to start sinking to the bottom, and you're going to eventually see the clear water above. It may take a little while, but it's definitely not dissolved. And you can even see if you look closely at the bottom of test tube number 10, there's a little bit of more dense white stuff down there. So that's the powder that can't dissolve. Meanwhile, the other samples were soluble, meaning they did dissolve and they ended up with a clear solution. These guys are our insoluble samples. So 6, 9, and 10. We don't know what they are, but we do know that 6, 9, and 10 go in this box. 6, 9, and 10. Those are the 3 that are insoluble. Now, how do I know what they are? Well, technically you can't, but we've narrowed it down. 6, 9, and 10 are in this box. Look at your flow chart on the next page. Here's that same box. This is where we had 6, 9, and 10. This is where we wrote it. They match from here to here. So you're going to compare. Now, here's the problem. At this point, there's 3 numbers in the box and there's 3 formulas in the box. We just don't know which is which. Is this first one, is this calcium carbonate, CaCO3, is that number 6? Or is that number 9? Or is that number 10? We don't know. We have to run more tests. So at this point, all you know is that 6, 9, and 10 are these substances, but we don't know anymore. Over here, this is everything but 6, 9, and 10. This Na2CO3, it could be 1, it could be 2, it could be 3, it could be 4. The only thing it can't be is 6, 9, or 10. So what do? Well, you're going to run more tests. As you progress through the activity, you're going to see directions that explain how to run each one of these tests. The next thing you're going to do is test with iodine for the presence of starch. If the iodine makes the sample turn kind of a deep blue color, that's our positive result that we're looking for. That's the interesting change. If it stays cloudy, or even if it turns a slight orangey brown color, this is boring. This is our negative result. This is nothing. This is not interesting, but this is interesting. So you are going to test and see if 6 does this, if 9 does this, or if 10 does this, but only 1 is going to do that. How do we know only one? Well, A, the directions tell you, but B, there's only one box that doesn't branch anymore. It's a dead end. This one is a dead end, doesn't branch. This one, see how it branches again? Then we hit 2 more dead ends down here. There are actually 11 dead ends. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. There's a dead end for each one of these samples. So when you're done, when you hit a dead end, you know something about a particular substance, or you know a lot of things about a particular substance. So for instance, let's take a look at H3BO3. It's in a dead end, but it started up here with all the rest of the solid white powders. Then it was in this box right here. Not a dead end yet, but we do know it's soluble, just like these other substances. Then we test it with phenolphthalein. You'll find out why when you read the rest of the lab. But it doesn't do anything interesting. NR, no reaction with phenolphthalein. So it's here, still not alone. Then we test it with NaOH, sodium hydroxide. It doesn't do this. It doesn't make a white precipitate, does. Magnesium sulfate does. That makes it stand alone, but this doesn't. Then we test it again. We get over here, and we see that it doesn't do what C2 or C6H12O6 does. It doesn't make an orange precipitate with Benedict's solution when we test it. It's over here. It's no result, stayed blue. Then we test it again with vinegar. It doesn't bubble. It's right here. Only the NaHCO3 bubbles. So this has no result, boring. And then finally, we test it with the universal indicator, and it's all by itself. So now we finally found something that makes this substance unique. But in the meantime, we have a whole list of things that we know about this substance. We know, for starters, these are properties. We know it's in the top group with all the rest of them. So we know it's a white solid because all of them are in that category because they're all white solids. We know it's in this category, the next little box, soluble 1, because it was able to dissolve in water. So we know it's soluble in water, but so were a lot of other things. So that didn't really help us too much, but it allowed us to keep going. We tested with phenolphthalein. The reason these turn pink is because they're bases. This is not a base. Acid, base, or neutral, it's not a base or alkaline substance. So that means it is either an acid or neutral. We just don't know which is which because phenolphthalein only tests bases. Oops. So now, what else do we know? After we tested it with phenolphthalein, we then came down here and tested it with sodium hydroxide. It didn't do anything interesting. NR, no reaction. So we know something about that. We know a chemical property. It's a boring chemical property, but we know a chemical property. This does not react with NaOH. Doesn't do anything. Then we tested with Benedict's. We added some Benedict's, or we will add some Benedict's, and we'll see, does it make an orange precipitate or does it stay blue? And it stays blue. It's boring, no result. The reason that it would turn orange is because it has a monosaccharide. This didn't turn orange because it does not contain a monosaccharide. What else do we learn about this substance by using this flow chart and the results of all our tests? It was here. Now we're going to go test it with vinegar. It doesn't bubble. NR, no reaction. It's boring. Doesn't react with vinegar. So it's boring, but that's a chemical property. We gave it an opportunity to react, and it didn't. So it does not react with vinegar. And finally, we get to the dead end for this substance. We test it with universal indicator, which is a pH test. If it's green, it's neutral. If it's orange-red, it's an acid. We now know that this is an acidic substance. And we know that because it's the only one to turn orange or red. And that's what universal indicator does. It turns orangey red in an acid. So this is an acid. So we just learned 7 different things about this particular substance. And if we took a new substance down here, oops, I want to circle it. If we took maybe this substance down here, we could trace it back and figure out more properties about that substance. And same thing with this one, and same thing here, and so forth. So we can follow this flow chart and find out a bunch of different properties. And eventually you're going to come to the one thing that's unique. In this case, it's an acid. Back up here, this is the only one that's insoluble, and it contains starch, which makes it turn the deep blue color with iodine. It's the only substance out of those 11 that has that combination of properties. So that's what you're going to be doing. You're going to be running tests and trying to find out, based on your results, what properties different substances have and what's their identity. All right, good luck.